Hi there, this is video number C9, and we're going to talk about permutations today, and this is the introduction to it. If you're getting a little tired and frustrated of those fundamental counting principle questions, well, you know what? I think they are the harder ones because they are the fussiest, and you got to remember the restrictions and whether there's repeats or not. Permutations are a little simpler, and I will show you some magic buttons on your calculator that you can use to make your life a lot easier. So, permutation, here we go. A dang subset, okay. A subset of fundamental counting principle where you're arranging a set or part of a set in a particular order. First of all, repetition is not allowed. So you know right away, that's gonna make life easier. You don't have to think, is it or isn't it? So if this is all the fundamental counting principle questions, there's a subset that are permutations. So what? Well, what it means is every permutation question you get, you can solve using the fundamental counting principle. But it doesn't work the other way. So here are going to be questions that, like the ones we were just doing, where it's odd numbers and even numbers and repeats and stuff like that. But every one of these, you can solve with the fundamental counting principle. Permutations is, honestly, it's a shortcut. I know, once I show you the magic on the calculator, you're gonna be so happy. Much, much simpler. And there's a formula for it instead of just having to draw every blank. But before we start, you have the skills, I know you do, that you can do these 8 questions. Just do them as a fundamental counting principle. Boom, do them right now. They're straightforward, they're simple. And remember, we're looking at order matters and repetition is not allowed. So please pause the video, do these questions, and then restart it or check the answer key in the back. Wait, I'm gonna see if you did that. All right, we have 7 toys on a shelf. And we're gonna arrange them. So 1, 2, 3, 4, 5, 6, 7 spots for the toys. And when I look at my pile of toys, there's 7 toys. I need to pick one of them to go in the first spot. So that's where I put my dolly. And now there are 6 toys left in my list. Well, now I'm going to put my teddy bear. Okay, what did I just do? I'm freaking out because I have a blank left and I already counted to 1. Oh, come on, take a look. I'm sure you were yelling it at the video. 4, I missed a number 3, 2, and 1. All right, that is 5,040. Yeah, I'll show you a magic button on the calculator. I know it comes later in the lessons, but I just want to use it now. All right, so to multiply quickly, instead of going 7 times 6 times, which is 5040, you can use the factorial button. See that one right there? Little X. See if I can focus better for you. There it is. Not the X and -1, but X with the exclamation mark behind it. That's called factorial. And that in math is a shortcut to multiply quickly. And it says, whatever number I put in, that's where I'm going to start multiplying. And I'm going to multiply by every number until I get to 1. So I can go 7. I have to do shift to get to this one. Boom, 1 shot. All right. So how many ways can you arrange the letters in the word uncopyrightable? Oops. Focus. There we go. Well, first of all, we have to know how many letters are. 1, 2. I got 15. Let me try again. 1, 2, 3, 5. Okay, so there's 15 letters. So what are we going to draw? 1, 2, 3. And then when we pick our first letter, there are 15 to choose from. Let's say we take out the U. And now we have 14. And let's say we get rid of that one, just because I can. And then 13. Okay, you guys know. 13. Okay, I feel more confident because I ended up with 1 in the last spot, not like up there where I screwed up my numbers. And I'm going to cheat and use that factorial button again because I don't feel like multiplying that all through. Oh, okay. Well, look at that. Not surprisingly, it's a really big number. 1.308 times 10 to the 12th. So this has, I think the first or second lesson I said every once in a while, your calculator is not going to be big enough to display it. And that's the only time you're going to get a decimal number. So this means if I took this whole number and multiplied it by 10, if I do that, can you see better? Yes, you can. It does show up, sort of. Is it little tiny times 10 to the 12th? So it's scientific notation. And it just means that its two equivalents are, no, I can't see very well, multiplying this number through by 10, 12 times over. So you got to make sure that you don't miss that little part there. If I went 15 times 14 times 13 times 12, see, it's still fitting on there, times 11, we'll put on my calculator, times 10, times 9, we're getting there, times 8. See how my display is filling up, times 7, oh, still fitting on there, times 6. Oh, you can see right now it flipped over. And it now has that because once I hit 6, there wasn't enough room on my calculator display to show it all. I guess if you're using your phone, you might get all the numbers, but this is good enough. This is good enough for me. All right. Now, next question. How many ways can you arrange 6 letters of the word uncovered? How many blanks do I need to put? 1, 2, 3, 4, 5, 6. I'm only going to use 6. I only need 6 blanks. But what am I going to start with? How many choices do I have here? There are 15 letters. Okay. So, and then I pick 1, 14, 13, 12, 11, 10. Much nicer than having to go all the way through that. There is a shortcut for that on the calculator, but I'm not showing that to you today. So I'm just going to do it the other way. 15 times 14, 13 times. There, now you can see better. 12 times 11 times 10. 3, 6, 0, 3, 6, 0, 0. There we go. So that makes it 3,603,600 different combinations, different arrangements of those letters. If you were a little leery and scared to try this on your own, I'm going to challenge you one more time. The rest of these are not really any more difficult. Pause the video. You've got to do the work by yourself and then turn it back on and watch the video and see that, yes, you got it right, or, oh, I understand. I can see where, see what I was thinking and what she was thinking, and I can see where my mistake was. And if that doesn't work, then come see me the next day in class and we'll work through it. All right, we have a 7-horse race. How many first? You don't need that, but I'm gonna fix my grammar. We'll start there to remind myself to fix it. And third place finishes are possible. So the trick on this question is how many blanks do you need? Do you need 7 because there's 7 horses? Or do you need 3 because you're looking at first, second, and third? Exactly. I only care about the first, second, and third. So first horse, second horse, third horse. So 7, 6, 5. That's going to be 210. And there we go. That's it. Okay. Number. Keep going. All right. How many 5-digit numbers can be formed by selecting digits from that list? 1, 2, 3, 4, 5. All right. Notice there's no 0 in the list, so life is a lot easier. And also remember, can't see it, but at the top of this page is about permutation, so repetition isn't allowed. So we don't have to worry about that. Then we start, we've got 9. And then we use 1, 8, 7, 6, 5. And that gives me 15,120. How are we doing? It's good, yeah. It's not too bad. Not nearly as fussy. Pardon me. I wiggled around. It's not nearly as fussy as those fundamental counting principles are. Remember, it's a subset. And truthfully, this, we're still using the fundamental counting principle. Now we need arrangements. 3 letters on the word Friday. Okay, so 1, 2, 3. And there are 1, 2, 3, 4, 5, 6 letters. So 6, 5, 4. So 30 times 4. Hold on. Jelly Bean is very barky today. All right. Anyway, there we go. Straightforward. 6 letters, use 1, 5 letters, 4. Okay. Now, 1, 2, 3. How many arrangements of 3 letters end in the word end in F? Okay, so this one is basically you have to do. I should have started. Because you really can't use permutations because it's got that restriction in it. So it's kind of a combination of the both. But that's why we do fundamental counting principle first. There's only 1 F in Friday. And then you can use the rest of the letters. So if this is gone, then you've got 1, 2, 3, 4, 5 choices, and then 4 choices. So sometimes like this technically is a permutation. And then when we put this all together like this at the end, it's a combination of the 2. That's going to give us 20. All right. Now, in how many ways might 15 runners finish a 10K race? Okay, so question. 15 blanks, 10 blanks. Think about what's going to happen. Okay, so you're standing at the finish line of this race, and you are going to watch the people come in. And how many people are going to cross the line? Should be 15, right? Ah, 15. We're going to start 15, and then we're going to 14 and 13, and you know what? I'm going to be lazy and get to 1 down there because I didn't realize it, but it's the exact same question over here. Sorry, this one. Uncopyrightable has 15 letters. It's 15 people racing, so 1.308. Oops. Times 10 to the 12. I'll show you one more time. My calculator. 15. And I want to get that X factorial button that's there, so I'm going to have to go shift. The shift will give me the light colored stuff on the back on this calculator. Do that again. Okay, clear. So 15. And then I go shift. And I want to, and I'm shifting because I want the stuff on the back, not the actual button. And there's my little exclamation mark. Or in math, again, factorial. Boom, there we go. And I just rounded it. There's no grand reason that I chose 3.08. It just seemed reasonable. So when I do that, okay, so 3 decimal places, so that's 7. There's a 6 coming after it, so I made it go bigger. And then I had to include the times 10 to the 12. So, yeah, there we go. Thanks. End of the video.